on the Schoology study guide, if you want to follow along. A state conservation agency reports that there are currently 3,000 deer in the forest. The agency also reports that the deer population is increasing by 10% each year. You need to write the equation of the deer population after n years. So did you have some of it and it's just marking it wrong, Keegan, or do you need like help setting it up?
I got it, but it's working.
Okay, what did you put? Because it might just be something really minor.
Really powerful. And procedures. And procedures. And
Okay. So initial value looks good. Those of you that have no idea where to start, use this version of our exponential function as a setup. So the initial amount looks good. It is growing, right? It's increasing by 10%. So I think that's what it was. And so since it's growing, it has to be the 1 plus. The rate, 10%, has to be rewritten as a decimal. We do have the right decimal for 10%. I think we just forgot to add it to the 1. And then, yes, this one wants you to use a specific exponent. So if you put it to the x, I do think it'll mark it wrong. It wants it to the n. And on your test, I know that they do want the condensed version of it, even though it might not say it in the instructions. Hold on, that's too many zeros. But just know, like, I made it to look just like the test. So it should have been something like this, and you can type it in on your test. The little Shift 6 button will give you that upward arrow so that it gives as an exponent. But let's just see the different answer options it could have been. There you go. So just like how I wrote it, let's see, I think I put some variations that could still be good, like if you put an extra 0 on the 1.1. So it could have looked like this, fully condensed. It could have had the 0. 1 plus the 0.1 I also accepted. Please don't do that on your test though. 1 plus 0.1 and 1 plus 0.10. I will, when I grade it, go back and give you points. Like I will look at everyone's response, but it would just be nice if it also just graded it the right way the first time, so I don't have to go back and add a bunch of points. But I believe all your teachers will do that as well. Go back and see if they could give you points, because it marks it wrong if you don't put it exactly the way they want it. All right, questions on others? Rebecca? One on this study guide? Okay. So we have functions shown in different forms, one as an equation and the other one as a graph. To save room, I'm going to put the equation on this side. And the question is, for each input-output pair, determine whether it satisfies function f, function g, both functions, or neither function. You should have seen something similar to this on your quiz before. So it's here again. It's going to be on your test again. So inputs and outputs. What else do we call the inputs? The x's. So all of these could really be written as coordinates. But inputs are your x's, outputs are your y's. So for the graph, when we want to test when the input's 0 and the output's 3, find where x is 0 on your graph. See where it touches on the line. Is that a y value of 3? So then it works for g of x, for sure. We need to see if it also works for f of x. So in that one, we're inputting 0. And we can let the calculator do the rest. highly recommend checking with the calculator. But I know that anything to the 0 power is what? It's 1, so then 3 times 1 is 3. So this one works for F, for G, for both, or for neither. It works for both, so you have to put both. Then here's the next input, I'll compare. 1, 6 and 2, 10. I'll say up here so that I have some more room. But 1, 6 and 2, 10 is what we're evaluating. So on the graph, find where the X is 1. See if where it touches on the graph is at the 6. So is this a Y value of 6? So then it does not work for G of X for this one. So this one you would say not G of X, but see if it works for the F of X. For the F of X, I'd have to plug it into the equation. We're plugging in a 1. You can use a calculator. I don't want to have to go back and forth between screens, so I just won't. Always do your exponents first, though. Remember that. What's 2 to the first power? And then what's 2 times 3? So it works for F of X. So not G of X, just F of X. So you pick the drop down that says function F. For the last one that we're checking, everyone with me so far, does it make sense? Okay. Last one that we're checking is when X is 2. So find where X is 2. See if that touches the line at the Y value of 10. Does it? So it works for G of X. See if it works for F of X. So if I plug in a 2, see what it gives you. What's 2 squared?
4.
And what's 3 times 4?
4.
Which is not 10. Right? So this one is just G of X, not F of X. So you have to evaluate both, even though they're in different forms. Good on that one? Okay. Questions on any others? And remember, you can do the constructive response too. Number 9. So number 9, the county of Rodville conducted a study to determine its deer population. In 2010, the deer population of Rodville was estimated to be 250. The annual growth rate of the deer population is expected to be about 5%. The graph below represents the population as a function of the number of years that have passed in the study since 2010. And this one, we're choosing the best domain and range. So that I mentioned will come up on all your tests moving forward. In semester 1, we talked about what each one is. Domain refers to all the what? All the X's. And the range refers to all the Y's. What's an easy way to remember which is which? Dr. XY. All right, just like a little corny way to remember. But what this is asking is, what's a reasonable value for my X's? And we're talking about number of years, and you do have some options. So all integers, all positive real numbers, or all whole numbers from 250 and above. So for this, you'd have to know what are integers. So I'll tell you. Integers are positive and negative whole numbers. So no decimals. Could it be all the integers? All right, no, because you can have a fraction of a year, can't you? And we're not really concerned about the negative amount of time, so I would not pick all integers. All positive real numbers. Does that include decimals? When they say real numbers?
Yeah.
It does. And all the positive ones. So this one's looking pretty good, but compare it to the last one. all whole numbers from 250 and above. Does that one make sense for our years? Okay, no. All positive real numbers. So domain is the x's, I see what my x is representing. But I have a fraction of a year, yes, I can, so all positive real numbers. Now for my range, which is my y's, the amount of deer. Can I have a fraction of a deer? So I'm not gonna take any that would give me decimals, right? What our options are. It says all whole numbers from 250 and above, what do you think? And then we also have all whole numbers from 0 to 250. And all positive real numbers. So the real numbers includes decimals, we can't have a decimal of a deer, right? So it's between these two, which one makes more sense? The top one because
It started at 250, not at 2.
because it started at 250 when they did their study. This is what the graph is. And you can see the line is going up, it's touching all these Y values that are bigger than 250. So you determine what's the most reasonable out of your options. Okay, questions on this one? Number 12, you said?
My old.
Okay, so
Wait,
the question was just about the last two. If anyone has questions about the others, we can talk about those. But it says the value of a motorcycle changes according to this equation, where V would be the value in dollars and T is the time in years. So the question was about these two. We can go over the others and keep those out. But the value of the motorcycle is blank at a rate of blank per year. Would you say that it is decreasing or increasing based on the formula? It's increasing. You have a few options to figure that out. You could graph it. It's increasing, sorry. You could graph it and just see, is it going up from left to right? But you could also remember how we set these up. And since it's talking about a percent change, because we want to figure out this percent next. Remember that we also have this variation of our exponential functions that can help us figure out what that percent change is. So if my middle part of this in the parentheses became 1.06, and we know it's growing, so it's increasing, we had to have added something to the 1. What would I need to add to 1 to get 1.06? What is my R? .06. And remember, when we would normally plug in values for R, we went from a percent to a decimal. Now we have to go from a decimal to a percent. So how can I convert that to a percent? Multiply by 100%. And when you do that, what's the equivalent percentage? Right, don't skip the actually doing it. That's why I don't tell kids, oh yeah, you move the decimal this way, move it that way. People always forget. So times it by 100% if you want to convert it back to a percentage. Was 0.06 times 100%. Increasing at a rate of what? 6%. All right, all of these are meant to trick you in some sort of way, but you need to remember, like, normally we're given the percentage and we have to plug it into the equation. When we're given the equation, we have to do all those steps backwards. Okay. So there's that. Do we have questions on the first two, anyone?
No, second. Like I said,
The second one, the equation, in the number 1.06 represents the blank. So the 1.06 as a whole. Growth factor. Okay, growth rate would be the 6%. So that would be my R. But the growth factor, remember, is another word for B. And B is what this chunk of it is. So when it's all together combined, that's my common factor. That's what I'm multiplying by each time. Okay? Good on the initial amount, I'm assuming. Okay. Other questions? Any on the constructed response? I'm gonna see if anyone else has a question. Yes. 4 on this one. So. Okay. So which number pattern is a function that can be described by an exponential equation with a common factor of 4? And select 3 that apply. So exponential equations, what setup are they always in? Like what's the general equation for them? Okay, good. So, and that's one variation, like I could make the TX, all that stuff, but
oh my,
boys, what of these variables represent my common factor? B. So when it says we want a common factor of 4, we want 4 to be what we're multiplying by each time. It wants the B to be 4, the one that's attached to the exponent to be 4. Otherwise, like in a pattern like this, if my common factor is 4, I should be multiplying by 4 each time. That's what your common factor is used for. So is -5 times 4 -1? It's not, so don't pick this one. Is 0 times 4 4? So then don't pick that one. Is 1 times 4 4? Is 4 times 4 16? Is 16 times 4 64? Is 64 times 4 256? Then that one follows an exponential equation pattern that would have a common factor of 4. So I will pick this one and we need to check all the others still. But that's what you're doing. Sometimes they try to trick you where they'll like change the pattern in the last few, like it'll look like it's multiplying by 4 and then not in the last few. So just always check. But down here, 20 times 4, is that 5? So don't pick that one. This one, 0.05 times 4, is that 0.2? Is 0.2 times 4, 0.8? Is 0.8 times 4, 3.2? Is 3.2 times 4, 12.8? Then you would pick that one. Okay, now the rest were there in equations. We're already almost there to the 3 that apply. So just kind of look at all of these. Which one has it where they're multiplying a 4 in the equation? This one? Not the very last one. That one has an exponent of 4. The one on top of it. And it looks like our setup. Remember, A times B to the exponent. And remember, B has to be the number that's attached to the exponent, not the exponent itself. Makes sense? Any questions? Okay, so just make sure if it says the common factor has to be this, that they're doing it all throughout. Or if they just want to know which one has an exponential pattern, it should be multiplying each time to get to the next number. Other question from the constructive response, from the puzzle piece,
Number 11.
Gabby? Okay, oh, it's the same one, okay. Number 11. So the ordered pairs shown in the table are generated by the function f of x. Which statements are true about this function? When x increases by 1, f of x increases by a factor. Factor means that you're doing what operation? Multiplying, good. So just kind of see, is 0.16 times 2.5, 0.4. Try it out in your calculator. I know since the number is getting smaller, it can't be that, so I'm going to use calculator, but do check. It's not increasing by a factor of 2.5. My y-intercept. You can tell your y-intercept on the table if they give you what x value. So your y-intercept by definition is whenever x is 0. Because if you look at the x, or if you look at the y-axis, all the x's are 0 there. So if they give you it on your table, great. Is that a y-intercept with 0, 0? No, it's 0, 1. So don't pick this one. That's not my y-intercept. 0, 1. And then we still need to keep checking. The function can be represented by the equation. F of x equals 2.5 to the x plus 1. So a way to see if that's true, the equations, you could try plugging in these x values into this given equation and see if it gives you these y values. But I'm also looking, the next two also give equations. So let's see which one it could be. Can you tell what the pattern is for this? Oh, wait, hold on. I think I made a mistake earlier. Let me double check this first one. So 0.16 times 2.5 is 0.4. 0.4 times 2.5 is 1. And 1 times 2.5 is 2.5. So we're gonna go back and select this one for sure. I didn't see it until I compared the 1 to the 2.5. But since it's multiplying each time, would you say that that follows an exponential pattern or a linear pattern?
Exponential is multiplying.
Exponential. If we're having to multiply each time in the y's to get the next value, then it should follow an exponential pattern. Not a linear pattern. One of these is given to us as linear, like this one. Don't take that one. So really, it's between these two. Because these are both exponential since the variable is the exponent. See which one could give you the answer? So I'm gonna plug in to the calculator. Okay. 2.5 to the x and 2.5 to the x plus 1. Okay, I'm gonna plug in the 1. And then I'm gonna plug in to the other equation. So when the x is 1, which equation gives me the right y value? that matches the Y value on our table. I don't know what I even did. Let me split screen so you can see it better. Okay. So right now we are testing the equations. We're testing where it's f of x equals 2.5 to the x and f of x equals 2.5 to the x and then plus 1. So what I plugged in was the 1 because I felt like that was one of the easier ones to plug in. Which one gives me an output of 2.5? Which equation should I pick? The one that is the 2.5 to the x. Because when I plug in my x values into this one, I do get the same y values that I'm getting in my table. So you can even try the other ones. When I plug in a -2, I get 0.16. When I plug in a -1, I get 0.4. When I plug in the 0, I get 1. Okay, so that's how you can tell the difference between the equations. Plug them in, see which one gives you the right answer. It can only be one of the equations. Do not pick both. Then it says f of x is an exponential function. Is that true? Yes, because it's multiplying each time to get to the next number. Because when I plugged it into this function, which is definitely set up as an exponential function, it gave me all these answers. So for this one, it's these 3. Doesn't mean it'll be that on your test, but it'll be similar, the similar way that you find out. Questions on this question? Okay, questions on others? Let's see. It shouldn't. It marks it as right. If you pick a wrong answer, it does take away from your right answer. Maybe that's why. Did you pick all 3 of these answers? Yeah, when you pick a wrong answer, Schoology penalizes you. Sorry. Because try not to pick wrong answers for the Schoology stuff. At least when I go back and grade your Illuminate test, I can give you partial credit. I won't penalize you necessarily. Or if I do, it's like half a point, not a whole point. Any questions on the study guide? We might have time for one more. Everyone's good on the constructed response? Okay, we have a request for number 5. So if you could relax a little bit. All right. So number 5, a herd of 175 buffalo were crossing the plains. Every day, the amount of buffalo in the herd increased by an average of 3%. The amount of buffalo B can be represented by an exponential function where D represents the number of days since the buffalo started. Which equation represents this situation? So our exponential functions are always in what format? What's our general setup for our exponential functions? Okay, so this is our general setup. Remember, A stands for initial amount. What is our initial amount in this situation? 175. So really, I'm down to two options just based on that alone, and like, I could switch the order. The A has to be the number that's not attached to the exponent. That's why it can't be these, because it has it wrong, it has it attached to the exponent. Now, it says that it increased. If it increased, should my B value be bigger or smaller than 1? It should be bigger. So when B is greater than 1, that would be growth. And these B's are different, that's why I bring it up. So I can't have it be this option because then that would be decay, right? So this is my answer. And that's because the rate that it's increasing by, you have to convert to a decimal. So this divide by 100 and you get 0.03. And then you have to, since increasing, add it to the 1. That's why this became 1.03. Good? Okay. What do you need to?
Well, obviously,
Can you upload it just so we can read it?
yeah.